We're going on to D, which is hydrogen will be produced at the cathode with electrolysis of pH 0 solutions, of which ions. Solutions, now again, I'm talking about ions. Okay? And now, there we're going to have to worry about in order for it to be reduced, it has to be, it has to have a reduction potential that is greater than that of the solvent. Hydrogen has a reduction potential of 0 volts. So anything with a reduction potential that's greater than 0 volts is going to be reduced by before hydrogen. So, you know, because remember we went back to that graph. Here we are. This is 0 volts. This was 1.23 volts. Okay. If I take an external power supply, I take two conductors, I place them in pure water. Once the voltage is 1.23 volts, I will start to see this is going to be the anode and this is the cathode. So once I hit this this voltage, I'm going to see oxygen bubbling off the anode and hydrogen bubbling off at the cathode. Now, if I take something like, let's take copper, which is 0.34 volts, which is Cu2 plus 2E going to copper. E naught equals 0.34 volts. Okay? Now, in this case, I take 1.23 volts minus 0.34 volts. 3 is 9. 11 subtract 3 is 8. So 0.89 volts. In other words, if I've got my power supply, I've got my electrodes, and I've got it in solution, once my potential reaches 0.89 volts, I'm going to see copper plating out at the cathode. And even if I go to a higher voltage, there's a bigger driving force for the reduction of copper than there is for the reduction of hydrogen, the solvent, which reduces at 0 volts. So that means that as long as there's copper in solution, okay, as long as that concentration is high, even if I have a greater than 1.23 volts, the copper is going to compete effectively because it's a greater driving force for its reduction. So copper is going to plate out. I won't see any hydrogen bubbling out. Now, after I've plated out all the copper from the solution, then I'll start to see hydrogen bubbles if I've got a greater voltage. But I could just use this voltage of 0.89 volts. Once I got that, that's going to be enough to plate out the copper. Okay? So, which hydrogen will be produced at the cathode with electrolysis of pH 0 solutions of which ions? So I would not expect hydrogen to be produced in this case. So, because copper has a reduction potential that's greater than 0 volts. Okay, which other ions are there? I've got zinc. Zinc's reduction potential is minus 0.76 volts. That's way down here. So if I put a zinc solution in and I put the potential in, I'm going to see hydrogen bubbling off at that at the cathode in the zinc solution. Now, what other ions do we have there? Nickel is minus 0.23 volts. So it's not going to plate out. So which ones are going to be the ones? This is one number D? Yeah. Zinc. Zinc plus 2, not copper. Nickel plus 2. Manganese 3 plus is going to be definitely reduced to manganese 2 plus at the cathode because it's 1.51 volts. The bromide ion, well, we're not going to worry about it. It's not going to be reduced any further. So hydrogen will be produced at the cathode electrolysis. Which ions? The one ion you might have missed is hydrogen, since it's an ion. Okay, does that make sense? So if I electrolysis of salts of zinc, nickel, and of acidic solutions will produce hydrogen at the cathode. Okay, copper won't. That was the only one in that field, along with the manganese 3 plus, that will not produce. The manganese 2 plus, I guess, because that's an ion, and hydrogen produced at the bromide ion. Since I'm being complete, I'm not worried about it being reduced any further. Okay? So that is the, this is very involved question, isn't it? Yeah. That's why this question is not going to be the first question on the test you see. There'll be a form of it, but it's going to be somewhere later in the test for strategic reasons.
So why is the zinc and nickel in there and they're below 0?
Well, they're below 0 because I'm talking about an electrolytic cell. I place them in an electrolytic cell. As soon as I put the potential of 1.23 volts in pure water, I'm going to get oxygen bubbling off the anode, hydrogen bubbling off the cathode. Now, because copper has a reduction potential greater than 0 volts, it's going to be reduced selectively. I don't even need as much potential. I need 0.89 volts in order to plate out copper at the cathode, which means it's got a greater driving force than the production of hydrogen. Hydrogen's produced here. It's produced at the cathode at 0 volts. So once I have 1.23 volts, I'm going to see hydrogen bubbling off here and oxygen bubbling off there.
So in an electrolytic cell, the 0.6 volts
we were talking about the interaction of the solvent itself with these materials. It was not with any external voltage being applied.
Oh,
Okay. Yeah.
So manganese and bromide are both above the 1.23.
Yeah.
Which would give you oxygen.
But the point is, this is the reduced form. Hydrogen is what's produced from the reduction process. You're not going to reduce bromide any further to bromine plus bromine minus 2 or something like that. Okay? And the manganese is the reduced form. The manganese 3 plus, that's going to be reduced.
But
So-
isn't the question just asking which ones will produce H2?
Which will produce hydrogen. So manganese 2 plus is already reduced. So it's got, manganese 3 plus would be reduced to manganese 2 plus in an electrolytic cell, in preference to hydrogen. Because it's like 1.51 volts. You betcha, it's going to be reduced.
Oh, okay. So you don't have to get below 0 to get oxygen bubbles to produce?
Well, no, we're not talking about oxygen bubbles. We're talking about hydrogen being produced.
Yeah.
But manganese 2 plus is already reduced. So it's going to be stable in water.
But isn't,
Or it's going to be not stable in water. It's going to be it's not going to be reduced further at the cathode. Okay?
Therefore, no H2 bubbles.
So hydrogen will bubble off in solutions of these salts. These will all give hydrogen. This will not. So this would be the answer. Okay? This question is very involved. Okay.
How many volts is it worth?
This question, you betcha. This is a tough question.
Is it worth a lot of volts?
Um,
Anything, come on.
yeah, it's worth some points.
Oh.